Okay, all right, let's go ahead and get started. So we're to find the slope and the y-intercept of each of these following equations. So let's go over this. Remember that the slope is the number that's on the x term, so the coefficient on x. So here the slope is 3. And then the y-intercept is the number that's all by itself. So here we've got the y-intercept is -2/3. Let's do the next one. Here we have got a problem because it's not yet in slope-intercept form. So we're going to have to add the 2 over so we can have everything all correct. So we've got now 3/2. Get 2 down there. X, 3 and 2 is 5. And then we're going to go ahead. I'm going to say here our slope is the number on the x, so that's 3/2. And our y-intercept here is the number that's by itself. That's just 5. For problem number 3, sometimes this one is hard to see, so I recommend, if you need to, rewriting it so you can see the slope and the y-intercept. That way we can see here's the slope is the number on x. And the y-intercept is the number by itself. And there we go. There's number 3. Now with number 4, all we're going to do is, this one is sort of difficult to contextualize with the other ones. Remember, this is a vertical line, just like this one's a horizontal line. The slope is at 0. And so the line is horizontal going through 4, right? But here, when it's x equals, it's a vertical line. And vertical lines always have the exact same slope. That is to say, they don't have one. The slope is undefined. And likewise, they don't have a y-intercept either. They're going vertical. They're never going to hit the y-axis. So the y-intercept here is also doesn't exist. It is undefined. All right. So that's it. Remember, if it's a y, if you've got it in slope-intercept form, you can just read it right off. There's the slope, there's the y-intercept. If it's not in slope-intercept form and you're confused, put it in slope-intercept form. If it's just y equals a number, that's a horizontal line that goes through whatever this is. So the y-intercept is just whatever this number is, and the slope will always be 0. And then if it's a vertical line, if it's x equals a number, the slope is undefined. It does not exist. The slope, there's no slope. And the y-intercept also does not exist. It is undefined. Okay, let's go over what we're talking about today. So today, we're going to be able to find the equation of a line that is either parallel or perpendicular to another line that we're going to be given. I'm going to tell you, this is, I picked this for today because, A, it's major review from Algebra 1, but also it's very simple once you get the hang of it. It'll take maybe 1 or 2 tries to be like, oh, I see what's going on. And then, ta-da, you're good. So, let's go over a couple things. So first of all, point slope form. This is point slope form. Y minus y1 equals m times the quantity x minus x1. But this form of the equation of a line is going to be a super duper excellent workhorse for you as you go forward through your math classes. Because they're never going to, once you get to, like, for example, I teach calculus. Once we get to calculus, I'm never going to tell you how I want the line to look. But I'm going to tell you what's the tangent line to this curve at this point. Well, all you need to do is you find the slope and you find the y-intercept. And then, or you find the slope and you find a point, right? If you find a slope and you find a point, you can just put it right in here. So M, just like you remember from slope-intercept form, M represents your slope. X1 and X2, those are your X and Y coordinates. So they're going to give you a point, 1, 5, 1's your X coordinate, 5's your Y coordinate, etc. Lastly, the X and the Y that are in that equation that are just sort of X and Y, a lot of people really, really badly want to like put stuff there. Don't put stuff there. There's no reason to put stuff there. There's nothing there. So the term dummy variables I actually learned when I was in college from a chemistry TA. And it just means these variables are going to sit there and provide structure and skeleton to the equation. So the y and the x, don't touch them, don't move them, don't do anything to them, leave them alone, and then move the numbers around them. Okay? That's all you got to do. So let's go over a couple examples and talk about what we mean when we're talking about these parallel and perpendicular lines, right? So when we're talking about parallel lines, we're talking about, when we're talking in terms of algebra, in terms of these equations, we're talking about lines that have the same slope as each other. So like, you see how this one has a slope of 3 and this one has a slope of 3? They have the same slope, therefore they are parallel. That's all we look for, nothing else. Obviously the y-intercept should be different. Otherwise they're the same line at that point, right? But like if they've got the same, if you're asked, hey, are these parallel? Well, they're asking you, do they have the same slope? If they have the same slope, then yeah, they're parallel. Perpendicular is a little bit more complicated. Here we're not talking about the same, we're talking about a very specific relationship that they have. Opposite reciprocal, so this one here is 4/3, right? This one here is -3/4. Right, notice positive to negative because opposite, positive to negative. Reciprocal, 4/3 to 3/4. We took the numerator and the denominator and we flipped them over. That's reciprocal. So you got to do both in order to make this work, okay? If you want to find the slope that's perpendicular, opposite reciprocal slope, it has to be. All right? So when I want to make a line and I'm given this type of information, let me show you what to do. So you're going through and you say, all right, well, I need to find the equation of the line that happens to be parallel to this one, and it has this point on the line. So a lot of you are going to make the same mistake that everybody else does, everybody else has, and everybody else will. You're going to try and reuse this equation in some way, shape, or form. Don't. There's only one bit of information that matters from this equation, and that's the slope. Remember, parallel lines have the same slope. Well, now I've got the slope. Do I need this equation anymore? No. Get rid of it. I'm going to scribble it out so we're not tempted to try and do anything else with this equation. It is meaningless now. We got the one part that matters. We have taken its useful things and then we have thrown it over our shoulders. Well, I know I needed m, but if I'm going to put it in point slope form, what else do I need? I need x1 and I need y1. Notice all I'm going to do is well, here's my x1, here's my y1, right? So let me write that out. Well, x1 is -1, y1 is 8. Well, now I've got my m, my x1, my y1. Point slope form time. Y minus y1 equals m. Here, I'm trying to times x minus x1. Let's plug it in. Y minus y1 equals m times x minus x1. Notice it's minus -1, right? So I'm going to have to clean that up. Minus a negative is a positive. Y minus y1 equals m times x minus x1. Ta-da! According to the way that this problem is written, all it wants is an equation, right? What is an equation? Does it matter what equation? No. So just do this one. This equation. It's here. Now, if they give you different instructions, like let's say in the blue it says make sure that this is written in slope-intercept form. Well, then you got to do slope-intercept form, right? So I'm going to put the extra information here in green. But this, as far as I'm concerned, this is the right answer if you hand it in to me, you know? I didn't ask you for nothing extra. So look, if we want to take this and make it into slope-intercept, 2 steps, right? Distribute. Remember, it goes to both, right? Don't just do it to the x, do it to both of them. And then add the 8. Ta-da! Here we have slope-intercept form. But again, unless you are specifically directed to put it in slope-intercept form, why would you? Who cares? Nobody, that's who. If they don't tell you a specific form to put it in, point slope form is 99.999 times out of 100 easier and better. But you do you. I'm not going to stop you. If you're the type of person you really like slope-intercept form of the equation and you want to do it that way, bless you. But it doesn't matter. What does matter is that you give this a try. You like that segue? I like that segue. What matters is that you give this a try. I'm going to put 2 minutes on the clock so that y'all can give it a shot. Go ahead. All right, so second verse, same as the first. Let's do this. My slope here, well, that negative sign means it's -1, right? Once again, do I need this equation any longer? No, I've taken all the good bits out of it. I'm going to throw away the husk. It's gone now. Say goodbye. My x1 and my y1. Let's put them out. -5 is my x. Remember, these go in alphabetical order. My y is 3. And then I'm just going to make my equation in point slope form. And again, do you have to put it in slope-intercept form? No. Will I? No. Y minus y1 equals m times x minus x1. And once again, 2 negatives make a positive, so clean that up. And -1 you can just write as negative, so I'm going to do that. Ta-da! All finished. Now if they ask you for point slope form, distribute the slope and add this 3 over to the other side. And ta-da, you're done. Y equals -x minus 2. Sure. So that's parallel. What about perpendicular? Perpendicular, all that means is instead of having the slope be the same, it's going to be opposite reciprocal. So once again, going to look at the slope. 1/5. That's not my slope because I want perpendicular, but it is what's going to tell us the slope. Flip it and change the sign. It was positive. Now it's negative. It was 1/5. Now it'll be 5/1. And again, do I need this equation anymore? No. Throw it away. It's been used. Thank it for its service and then throw it away. Marie Kondo that equation. Now x1 and y1. x1, well, that's 15. y1, that's -4. Now, once again, y minus y1 equals m times x minus x1. Two negatives make a positive, so fix that. And there you go. Again, I am following the directions to the letter. Why would I do more? You ain't getting paid to do more. I ain't getting paid to do more. I'm not doing more. They ain't paying me for that. Give this one a try. Okay, let's go over this one now. So once again, all we care about is this slope. The slope is what tells us the answer. The rest of it, throw it away. That's the only part we need. And then since we're doing perpendicular, opposite reciprocal. It was negative, now it's positive. It was 3/1, now it's 1/3. Then do your x and your y. x1 and y1. What are they? x1 is -3. y1 is 7. Then just put it right where it goes. Y minus y1 equals m times x minus x1. Two negatives make a positive. And then there you go. Again, if they ask you to do slope intercept form, that's okay, but that's a wholly separate thing that they're specifically asking you to do. If they ask you to go from here and write it in slope intercept form, remember it's just 2 steps. Distribute, and then add the thing over here. And that's it. But this, right here, this is the better answer like all the time, pretty much, unless they're specifically telling you slope intercept form. From me to you. If you're not talking to a robot that specifically wants something, this answer is always better. I speak from the land of calculus where we produce this equation a minimum of once per class period, sometimes 3 or 4 times per class period.